Take a look at some of these tanks together. So this one, the customer says almost the same size fish. And this person had mostly 5s and some 7s. Those are pretty similar size. And I just want you to start thinking about this number you see right here, standard deviation, 0.92 grams. So that's something we're just going to be keeping an eye on. Let's look at this one. So this one, all the same exact fish, okay? And this one, you can see standard deviation here, 0 grams. So there is no deviation, even though you don't know exactly what standard deviation is yet. Let's check out this one. So you might think, oh, similar, right? There's a collection, but this one is saying a bigger deviation. It looks like this one's more spread out. Let's check out this one too. I'm seeing some bell-shaped kind of action. This one's more like 1.1. And this one, oh, someone did a switcheroo on me. One of them seemed more spread out. So it seems like when it's more spread out, the standard deviation is larger, maybe. We don't know yet. Okay? So we're going to go to the next one. And on this one, oh, it double-clicked me. We got some lag going here. So here, what you're going to do is you're going to look at the 3 different fish tanks. Tank A, B, and C. And you're to kind of come up with the theory of what the standard deviation is measuring. So the standard deviation you can see at the bottom of the tank, there's A, there's B, there's C. So start to develop a conclusion. Okay, why do you think it's different? Okay, so some things I just want to point out. I'm going to give you about 30 more seconds. A has 3, B has about 1, and C is right in between with about 1.5. So comparing the 3 tanks, think about A is the biggest, B is the smallest, and C is in the middle, and why that might be for that number. So what might be happening in each tank to make those numbers happen. So I'm just going to point out some of the answers here. Carla here said measures the size of variability. Something for average, how spread out the data is, how far away from the mean. This person is looking like they're comparing it to the MAD, an average, distribution, amount that's spread between each data. So we're just noticing, right? Big numbers maybe are spread out, small numbers are closer. That seems to be what a lot of people are thinking. So we're looking at distribution and variability is what it sounds like. So next, I want you to do the best to make a fish tank that has the largest standard deviation possible. So here's some stuff I want to try. If we're talking about spread, I'm going to try just spread them out. So I'm going to drop 2 of each. And I'm at 3, so that's like a bigger number than I saw in some of those other ones, so that seems pretty spread out. But right now, the middle is somewhere in here. So if I want to spread it out more, I'm going to try maybe the smaller ones. Let's see what they say. I'm going to try to spread it out more by leaving out the middle one. And I got a little higher, 3.07. So now I'm going to try this. So if the middle is somewhere around like 5.5, if I put the extremes, I will get the biggest standard deviation. So it looks like, to me, this number means how far away am I from the middle? Anybody get higher than 4.5? Oh. Yeah, what'd you get? 4.41 would be almost 4.5. Did you have like one extra little?
Yeah.
Yeah, so that's close. But 1, 2, 3, 4, 5. Let's see. I think 5 and 5 is just a tad bigger. Just a tad bigger. All right, next up. You need to get the lowest you can. You need to get the lowest standard deviation possible, but it can't be 0. So let me show you how you'd get 0. All of one fish is 0. You can't have 0. You need the lowest possible, but not 0, please. So I'm noticing that 4 and 5 are the closest 2 together. Right? Because 1 to 4 is a bigger jump, 5 to 7 is a bigger jump. So I'm going to look at 4 and 5. And then I'm actually going to spam the 4 here. And here's why not having them perfectly equal makes it even smaller. If I have all these 4s, is the center closer to 4 or 5? If I have all the 4s, is the center closer to the 4 or the 5? The 4, right? So there's only this one that's further from center. Where, if I have equal number, in the middle, 4.5 is the center, and it's wrong in both directions. It's a little bit bigger. So you can do it by spamming the 4 or the 5 there to get the lowest, because it's going to move the center toward the majority of the data a little bit. All right? So again, we want it to be as center as possible. And why did I pick 4 and 5 versus the other ones? They're only 1 apart, right? And it's looking like it deals with variability. So next, you are going to have this fish tank you're starting with, and you need to try to increase the standard deviation. So what I'm going to choose to do is I'm thinking like this is the middle somewhere in here, and I need to increase it. So I need far from middle. So what should I add to get far from middle, you think? A 10?
1 and a 10.
I got a 10.
1.
And a 1, so I'm stretching it both directions. Let's keep doing some 1s and 10s, see what's up. I'm stretching both directions. 3.81. So if you just add 1, it only pulls a little in one direction. If I stack how far away it is, so it looks like standard deviation matters, both sides being stretched from middle. Next up. Here are some of the masses of fish in a tank. I want you to take your best guess at which one has the largest standard deviation, or which one has the largest away from center. Best guess. You can't get it wrong. But you have to have a reason for your guess. I'm not going to tell you the answer. I'm going to show you how to figure it out. So, you can watch this little video, but you can just watch me do this. Okay? We're going to see how to calculate the standard deviation using our calculator tube. So the calculator is right here. And there's more than one way to do this. This video has you click on the function and go down here to find the standard. I like to just type it. And in fact, I kind of like how we did it before, where I set up my set of numbers. So 1, 2, 3, 4, 5. And then down here, I go standard. So it's STDEVP. And then I like putting the set A. So the standard deviation for 1, 2, 3, 4, 5 is 1.4. So I'm going to show you. I made my set. And then our standard deviation is STDEVP. Now, if you forget what to type, again, you can go here to the function and go down to, in statistics, STDEVP, and it's there as well. Functions, or I just type it. So you're going to practice right now doing this with, how did I get that to go away last time? And that won't go in. So you can either type it, but you're going to do this list of 3, 4, 6, 7, 7, 9, and I'm going to be able to check if you're doing it right in the calculator. So now that you know how to use the calculator, that set that we guessed with, you're going to use the standard deviation from the calculator to arrange them from smallest to largest deviation. So smallest to largest, the calculator's right up this blue thing I clicked right here. Okay, and you're going to use the numbers to make it happen. I typed in all 3 of my sets, A, B, and C, over here in the calculator. So next I'm going to do standard deviation of A. I got 0.76. Standard deviation of B. I got 2. So B is more than A, so I'm good so far. And standard deviation of C is 0.74. Ooh, so that's close. So 0.74 is a little smaller than 0.76. So, wait, did I just do that wrong? I just did it wrong. Least. So it should be CAB. I just went greatest to least. So here they are. Least to greatest. You can see 2 has the most. 2 has the most for B. C has the least. Now, which 2 are really close together? C and A, like really close. Like we can't look at them and know. That's some value in having a number that tells us. Because then the number, we can look at the number and compare. and then we know. Next up, you're going to test out what happens to our set if we do these things. Remove 7, add 0, remove 3, add 4, increase everything by 1. You're going to use your calculator to make your data set work for you. All right? So A equals 1, 2, 3, 4, 5, 6, 7. And then you're going to manipulate your number set with the standard deviation to see what happens as you do those things. I think it's a good idea to make a prediction and to see if the prediction comes true. Start messing with our data set. So we're at a standard deviation of 2. If we remove 7, it goes down to 1.7. That's because the outside's getting closer to the middle. So that one does not increase it. Now, we're going to add a 0. And so we added on the low end, far from the center, and it made it go up to 2.29. So it went up. So the 0 made it go up. That's because I pulled away from the center with the 0. Next, I'm going to remove 3 and see what happens. So 2 is base. 3 is kind of close to the center, right? This one could be interesting. When I remove 3, it went up a little bit. That's because I removed a center thing, which would pull it tighter, right? Let's add 4 and see what happens. 4 took it. Oh, that's a 44. Oh, and I don't have my 3. There we go. And that pulled it closer to the center. It's tightening up the center because the center is right around 4. So that didn't make it go up. And I'm going to increase everything by 1. So instead of 1, 2, 3, 4, 5, 6, 7, I'm going to go 2, 3, 4, 5, 6, 7, 8. And it is still 2 because my distance away didn't increase. My distances away are still 1, 2, 3, and so on. Okay?
So wait, would that count as a check?
No, it did not increase. It stayed the same at 2. So those should be my 2 check boxes. So next up, I want you to explain what the average and standard deviation say about these tanks. General. What does it say about these tanks? All right, here's what I'm going with. Tank A. Large fish. At 20 grams, right? The biggest fish we were throwing in tanks were what, 10 grams? And I'm going to say in tank A, most fish are about 20 grams. And how do I know that without knowing anything else? How do I know that? Yeah. The mean is 20, but I know they're all close to 20 because the standard deviation is really low. That means it's not spread out much. A bunch of stuff right around 20. Okay? Now let's look at tank B. Tank B, the average is kind of small. It's at 5 grams, but what does this tell me? Do I have a lot of fish around 5 grams?
No.
No. So we could have fish that are quite a bit bigger and smaller than 5. Where in the first tank, tank A, a lot of them are right around 20. That second number, the standard deviation, describes variability of our data, okay? Do you see how one is tight data and one spread out? We don't even need to know what it is, right? This is how we would make our comparison. Where the middle is and how spread out it is. That's all the information we get from the mean and the standard deviation. And I hope you're noticing the standard deviation is actually a lot like the MAD. It's pretty similar. And the way you calculate it, which we're not doing right now at all, is also pretty similar.